Hello, today we are going to learn about the quadratic formula. So the quadratic formula is a common math formula that allows you to solve a quadratic equation. We have already discussed two other methods for solving quadratics. The first was factoring. Then in the last several sections, we talked about how to solve by graphing, where we graph our parabola and then look at the roots or the x-intercepts as our answers. When something can't be factored and its roots are not perfect whole numbers, we then have to use the quadratic formula to find exact answers. When something can't be factored, it doesn't mean that it doesn't have any roots or solutions. It just means that they aren't necessarily factorable. When we graph, we can visually see our roots, but often they are not on perfect whole numbers, and therefore we can't get an exact answer. When we use our quadratic formula, we have to make sure that our quadratic equation is in standard form. So we need to have something that looks like ax squared plus bx plus c equals 0. You're already familiar with a, b, and c. A is always the number in front of x squared, b is in front of the plain old x, and c is the number all by itself. We're going to plug the values of A, B, and C into this big formula and then plug and chug and solve to get our answer or answers. If you haven't done so already, please check out the 2 videos of my kids doing the quadratic formula song. If my 3 and 8-year-old can memorize the song in 2 days, I have faith that you can as well. Play it on repeat until you know every word. Okay, before we get to actually using the quadratic formula, we're going to talk about just a part of this formula, and that's the part underneath of the square root sign here. B squared minus 4ac is something called the discriminant. So the discriminant is just a number, and we find the number using this part of the formula, b squared minus 4ac. The discriminant tells us how many answers a quadratic equation has. It doesn't tell us what the answers are, just how many exist. You may remember from graphing that it's possible to have one solution, 2 solutions, or no solutions. And we can tell based upon where the graph intersects the x-axis. Well, the discriminant tells us the same thing. If you calculate your discriminant and you come up with a positive number, that means that you have 2 roots. Or in other words, if you were to graph, you might have something that looks like this, where your graph intersected the x-axis twice. If you calculate the discriminant and you get a negative number, that means that you have no solution or no roots, and perhaps the graph would look something like this, where it never intersects the x-axis. If you calculate your discriminant and you get the number 0, exactly 0, that means that there is one solution. And that was when our vertex sat on the x-axis, like this. So the discriminant doesn't tell us what the answers are, but it tells us how many answers there are. So let's practice finding the discriminant in questions 1, 2, and 3. So if you take a look at question number 1, make sure first of all that the equation is in standard form. Number 1 is not in standard form. We need to move this minus 50 over to the left by adding it. So we have 2x squared plus x plus 50 equals 0. Like we've been doing with our graphing, we're then going to pick out a, b, and c. So a is 2, b is 1, and c is 50. Then to find the value of the discriminant, we're using our formula b squared minus 4ac. So here we have 1 squared minus 4 times a is 2 times c, which is 50. 1 squared is just 1. 2 times 4 times 50 is 400. 1 minus 400 is negative 399. So our discriminant has a value of negative 399. Because that's a negative number, that means that this equation has no roots, no solutions, no answers. When you take a look at question number 2, our equation is already in standard form. So we can pick out A, which is 1, B, which is 8, and C, which is 16. To find the discriminant, we plug those values into B squared minus 4AC. That's 8 squared minus 4 times 1 times 16. Then 8 squared is 64 minus 4 times 1 times 16 is 64. 64 minus 64 is 0. So our discriminant has a value of 0. When you get a value of 0, that means you have exactly one solution or one root. In question number 3, we do not have standard form. In order to put this equation in standard form, we're going to add 5x to both sides. So this will become x squared plus 5x minus 6 equals 0. Notice the terms are in descending order. So A is 1, B is 5, and C is negative 6. To find the discriminant, we plug into our formula b squared minus 4ac. We have 5 squared minus 4 times 1 times negative 6. 5 squared is 25. Now, when you multiply out the other part, be very careful. You're multiplying negative 4 times positive 1 times negative 6. Negative times negative makes a positive. So this sign changes to plus. 4 times 1 times 6 is 24. And 25 plus 24 is 49. So our discriminant is 49. And since that's a positive number, that means that this equation has two solutions or roots. Okay, when you flip over to the back, we're going to look at a couple of examples of actually solving an equation using our quadratic formula. So first, we need to make sure that our equation is in standard form. Question number 4, we do have standard form. Then we're going to identify A, B, and C. In this question, A is 1, B is 7, and C is 6. When we look at our quadratic formula, it says x equals negative b, so we plug in negative 7 plus or minus the square root of, make yourself a big square root, and then underneath of the square root sign, we put b squared minus 4ac. That's our discriminant. So here we're going to plug in 7 squared minus 4 times a is 1, c is 6, and this whole thing gets divided by 2 times a. Okay, when you do the quadratic formula and you're calculating a value, you have to do it piece by piece. So the first thing I'm going to do is clean up underneath of the square root sign. So I now have -7 plus or minus the square root of 7 squared is 49 minus 4 times 1 times 6 is 24. And this is all divided by, I'm also going to do 2 times 1 in the denominator, which is just 2. Okay, then still underneath of the square root sign, 49 minus 24 is 25. So I have -7 plus or minus the square root of 25 over 2. Now I'm actually going to take the square root now that I just have one number under the radical. So I have -7 plus or minus the square root of 25 is 5 all over 2. Okay, now that we're at this point where we have plain old numbers for each part, notice that plus or minus sign. Plus or minus means that we have to do this expression once with a plus sign and once with a minus sign. So we're going to end up getting two answers in this question. So now I'm going to have x equals -7 plus 5 over 2. But I also have x equals -7 minus 5 over 2. So I'm going to make two expressions, one with a plus, one with a minus. -7 plus 5 is -2. -2 divided by 2 makes our first solution -1. Excuse me. For the second expression, -7 minus 5 is -12. -12 divided by 2 makes our next answer x equals -6. So for this question, we have two solutions. X is -1 and x is -6. Okay, for question number 5, we're going to use our quadratic formula again. This time we do not have standard form. So let's begin by moving this 12 to the other side by subtracting it. So now we have standard form, x squared plus 11x minus 12 equals 0. We can pick out A, B, and C. So here A is 1, B is 11, and C is -12. Okay, then we plug our values into our quadratic formula. So x equals -b, so -11, plus or minus the square root of, big square root. Underneath, we put the discriminant. So b squared, so 11 squared, minus 4 times a is 1, times c, which is -12. And this whole thing gets divided by 2a. Whoops, but we should plug in a. So 2 times 1. Let's try that again. Okay, now we can start cleaning up. So underneath of the radical, I'm going to start with 11 squared, which is 121. Then minus 4 times 1 times -12. Negative times negative makes this positive, plus 4 times 12 is 48, all divided by 2. Now, still underneath of the radical sign, 121 plus 48 is 169. Now that I have one number under the radical, I'm going to take the square root. So the square root of 169 is 13. So that gives me negative 11 plus or minus 13, all divided by 2. Once I've gotten rid of the radical, I can then split to find my two answers. So the first one is going to say x equals negative 11 plus 13 over 2. And my other answer, x equals negative 11 minus 13 over 2. So for the first one, negative 11 plus 13 is 2. And then 2 divided by 2 is 1. For our second expression, negative 11 minus 13 is negative 24. Negative 24 divided by 2 is negative 12. So we have two answers, negative 1 and negative 12. And for our very last question, this is in standard form. Question number 6 is x squared minus 55 equals 0. Even though there is no plain old x term, this is still in standard form. So here we have a is 1. Since there aren't any plain old x's, b is 0. And c is negative 55. When we plug into quadratic formula, x equals negative b, so negative 0, plus or minus, big square root, b squared, so 0 squared, minus 4 times, a is 1 times c, which is negative 55, all divided by 2 times a, which is 1. Just like before, we're going to clean up underneath of the square root first. So x equals negative 0 doesn't do anything. 0 doesn't add or subtract, make a difference. So I'm just going to ignore it. So now I have x equals plus or minus the square root of 0 squared is just 0. Negative 4 times 1 times negative 55 is positive 220, all divided by 2 times 1 is 2. 0 plus 220 is just 220. And now we can take the square root of 220, which is not a whole number, but that's fine. Just type it into your calculator. So we get plus or minus. The square root of 220 is about 14.8. And this is still divided by 2. Like before, we're then going to split into our two separate answers. X equals positive 14.8 over 2. And x equals negative 14.8 over 2. So our first answer is 7.4. And when we divide negative 14.8 by 2, our next answer is negative 7.4. As always, please make sure you let me know if you have any questions. Complete the homework with this section. Have a great day.